So the next topic is factors and exponents. So other factors and exponents, we have forms of exponents and exponents of special numbers. So factors or factor in mathematics is any one of two or more numbers multiplied together to form a product is what we call a factor. So if we have two numbers that are multiplied together, you can say they are factors. So you can say 2 and 4 is a factor of 8. Because when you multiply 2 and 4, you will have 8. So the factors of any given whole number, numbers such as 1 and 2 and 3, can be evenly divided by 1. Because when you divide them by 1, they still remain themselves, they do not change. So for example, since 6 is a product of 2 times 3, and 2 and 3 are factors of 6, then the decimal number will be 1.5. The decimal number 1.5 is not a factor of 6 because when you divide 1.5 by 2 or 3, you will not get a whole number. So you say it's not a factor of 5 or 6. So that is that. Then when you look at 2 or more numbers may share several factors. For example, you have 18 and 24 can be divided by 1, 2, 3, and 6. So these numbers are called common factors because they are all divisible by 1, 2, 3, and 6. So they become common factors instead of a common factor because there are plenty of them. So mathematically, you can see how it's represented in this equation. So again, let's look at exponents. So exponents basically are terms that are raised to any power. So if you use, for instance, say an exponent is usually written as a small number or letter at the right hand or the upper right of the base expression, as in, say, for instance, you have x raised to the power 2. So this is an exponent equation, which is read as x squared, and it also means x times x. So the terms contains exponents. Terms containing exponents are also referred to as power of their basis. So when you see something like this, you can say this is an exponent of x, which is 3. 3 is an exponent of x. 2 is also an exponent of x in this example. So in computation, exponents obey certain rules called the law of exponents. So these rules must apply or must be applied for you when you are looking at multiplication in exponents and all that. So for instance, in example 1, you see that x is raised to the power n times n x raised to the power n. What it simply means is that you must add the powers of x to get the exponent of that x. So for example, if we have 2 raised to the power 2 and times 2 raised to the power 3, it means that we'll have 2 raised to the power 2 plus 3, which is equals to 2 raised to the power 5. So when you multiply 2 by 2 in 5 places, so 2 times 2 times 2 times 2 times 2, that will give you about 12. And then when you take this raised to the power 2 and this, you see that you have the same answer. So sometimes when you have the same exponential powers but different base, you can have it as xy raised to the power n. So for example, we have 2 raised to the power 3 dot 3 raised to the power. So we can multiply the 2 and just raise them by their common powers, which is what we have here. So this is very important for you to understand when dealing with exponents. So that's the same thing that is applicable in this slide. So you see that a fractional exponent of the form x raised to the power n minus n indicates that taking the nth root of x raised to the nth power, which is what is denoted by n square root x raised to the power n. So for example, if we have this 2 raised to the power 2 over 3, then it just be equals to 3 square root of 2 raised to the power 2. So that will give us the answer we are looking for. So now exponents can come in different forms. They can be a square, cube, and so on. So when it's a square, it simply means we are just squaring those numbers. So for instance, if we square 3 by 3, we get 9. Square 4 by 4, we get 6. So and so on. Then for cube, it's just simply saying that that particular number is raised to the power 3, which is also the same thing as multiplying the number by itself in 3 places. And that will give you 1000 in the case of 10 raised to the power 3. That will give you 3,375 when 15 is raised to the power 3. So based on the above, we can easily find the cube root of any number by just multiplying the number by itself raised to the power that is being expected. Then we have forms of exponents in negative numbers. So when you have negative numbers, the exponents can also be in negative form. So like here in this case, we have minus 10 raised to the power 3. Please, this is raised to the power 3 and not 10 times 3. So when you do that, you see that 10 times minus 10 times 10 minus 10 times 10 will give you minus 1000 and so forth. So that's also the same thing that you will see here. So another example is when you have minus 7 times 6 times 6 will give you the same minus sign. So the minus sign does not change as long as you have it multiplying everything in the brackets. So then we have exponents of decimals. So what we mean by exponent of decimals is simply saying that you can have decimals that are raised to a certain power and you just multiply them as you go along. So if you look at in this case, we have 0.18 multiplied by 0.18, which is going to give you 0.3324. So it's just a similar process. Yeah? So you see that the same thing happens here. So for example, you have 4.93. There is only a 1 decimal place, and then the exponent is 3. So this is 4.9 raised to the power 3. 4.9 raised to the power 3. So 1 decimal place, and exponent is 3 because it's raised to the power 3. So when you do that, you multiply it by 3 times, you get that answer. So then we have exponents that are fractions. So you can have an exponent that is in the fraction form, which is what is explained here. So go through the slide, you will see where we have 5 times 5 times 5 times 5, which will give you 625. Now there is a negative exponent. Negative exponent in the sense that you have, like for example, we have 4 minus 2, which is equal to 1 over 42. This one you divide it by itself, you have 1 over 16, and 1 over 16 is equals to 0.0625. So similarly, you have the same thing in the next equation. So that's that for exponents and factors.